Have you been struggling trying to figure out how to get started with a CNC router? Well, you're not alone. Everybody's kind of gone down that path, and I'm hoping this video might make it a little bit easier for you. We're going to be working with the Sainsmart 4040 Pro Max. This is a benchtop CNC. It's not the cheapest out there, but it is a very capable benchtop machine that's very approachable for a lot of people, has some expandability, and we're going to be pairing that up with the Easel software, which is one of the easier ones out there because it kind of steps you through a lot of the processes and has a lot of checks in there to make sure that you are as successful as possible. But that being said, it can still be a little intimidating, and so I'm going to step you through the process. We'll get the machine set up in the software. I'll talk a little bit about bits and hold down methods, and then we'll run through a couple of projects just to kind of help get your feet wet, get you through the software, figure out setting up the project and getting zeroed in, all that, so you can be successful with your first couple projects on a machine just like this or very similar. So if that's something that interests you, you want to find out more, stay tuned. I'm going to jump right into it. As I mentioned, we're going to be working with the 4040 Pro Max from Genmitsu and Sainsmart, and I feel this is a nice balance between portability and a compact unit that's not as intimidating. Maybe you don't have a lot of room. This is something you can set on the bench and actually move off there if needed. But with its 700 watt trim router, it's got an ER11 collet that we can swap out for 1/4 inch and 1/8 inch bits. And its general construction lend it to be pretty well robust, to not be so weak as you can barely get projects done, but also not break the bank. So if you're looking for a starter CNC machine, check out my video on this one. It is one of the ones that I find is great for jumping in and not being limited by a super cheap model, but also not being in your $2,000, $3,000 really committing to it range. So that matters because when I'm talking about the bits and the end mills that I'm using, this setup does drive larger bits. We're going to be using some 1/4 inch bits in here. We may also drop down to some 1/8 inch bits for some projects. If you have a smaller CNC machine, say as the Cubico or some of the others, you may need to scale things back and use the 1/8 inch bits, but a lot of the theory and the operations are going to be the same. Feeds and speeds vary a lot between types of material and the type of machine and spindle and rigidity you have. So that is one thing that you're going to have to kind of get a feel for. The nice thing with Easel is their rates are very, very conservative. They're set up for kind of your more hobbyist, lower end machines to not break everything at the get-go. We'll actually be stepping up our speeds as we go through it. Speaking of bits, there's a plethora of them out there. And it can be confusing. So I'm going to recommend that you look at just a few. And I do like my Jenny bits from my friend Cody over at Cadence Manufacturing. He makes some nice ones from the 1/8 inch Jenny bit, which will work on a lot of these machines all the way up to some very large industrial size bits. But they can be a little bit more than what you want to jump into right away. As a beginner, you may be prone to mistakes and breaking bits. I will have links down these below, but knowing that not everybody wants to work with these, SpeedTool has a couple of different sets of kind of a beginner setup that you can get the set for around $20 to $25, and it'll have 3 or 4 bits in there that will get you started. The next thing we need to worry about is holding down our material. As your router is interacting with the material, there are forces side to side, sometimes pulling up, sometimes pushing down. So you need to hold your material to your wasteboard securely. Now, Sainsmart Genmitsu do include some clamps. They generally look like this. They're made out of aluminum and steel posts, usually have a knob up top. And these will work. They get threaded down into the holes of the spoil board and then they clamp down on the material. What I don't like about them is that A, they're metal, and as a beginner, if you don't 100% know your tool pathing and that they're going to avoid them, you can drive a bit right into these. And they also stick up higher. So if your Z height isn't quite up high enough, again, it can run into these. So while they work, I do recommend a couple different methods. First off, if you have a 3D printer or have access to one, you can print yourself some simple 3D printed clamps. These have a slot in here that a 6mm bolt will go down into, and that will clamp down. It has kind of a lever action off this foot, and this will capture the top of the material. also hold the side and clamp it down. If your end mill catches this, it's no big deal. It's simple plastic. It's probably going to go through it. And if you have your own 3D printer, these are super fast and super cheap to make. So they're kind of like a nice safe way to get through it. There will be a metal bolt in there, but hopefully that's much more out of the way. It's low profile. It's not likely going to hit that. Another option is to use a form of double-sided tape. Now I have used some lightweight, this is like indoor light traffic carpet tape. This is a double-sided tape. And so you put that on the back side of your material and then press it down on your board. Does a pretty good job of holding down as long as you're not being too aggressive and as long as you have a fairly clean spoil board. I've used some of the heavier woodworking tapes as well. The problem with those is sometimes they're almost too sticky and you can cause some damage there as well. But that generally does hold things in place pretty well. The other option is to use some typical just blue painter's tape. You put some on your spoil board, you put some on the back side of the material for your holding down, and then you get yourself some CA glue and you tape the pieces of, you glue the pieces of tape together, pressing them down. CA glue will set up fast, or you can use some accelerator to make it faster. And that acts as a double-sided tape, but it's very easy to pull the tape off of the material of the wasteboard, but it has pretty good holding power. This can be nice when doing through cuts because it will still hold the inside and the outside. So in case your tabs aren't solid or you want to do it without tabs, this can still hold your material down, but you do need to be careful that there isn't too many forces side to side pulling that out or pulling it up off there. So those are some of the typical hold down methods. I've used both the clamps and the tape method with success on all sorts of operations. And just over time, you'll get used to what works well for you. Now let's talk a little bit about material that you should use. It's going to be very tempting to use maybe some cheap plywood or some cheap softwoods like pine, basswood, poplar, things like that. And while they will work, you're going to have a tendency to have more chipping and splintering from those softwoods and those plywoods. And so maybe use them just to get a feel for basic operations. But when you really want to dial in, what am I doing and am I doing it right? You're going to want to look for some better material. And so if you have access to hardwoods and all the finishing things in your own shop, great. You do want to make sure you have, flat and square material. Otherwise, I recommend going to your big box store, go to Home Depot, Lowe's, Menards in the Midwest, pick up some dimensional hardwood. Maybe look at the maples, maybe look at the oaks, as they are going to have a stronger, tighter grain. They're going to be less likely to kind of chip out or splinter out or have that kind of just that softer grain to them that's going to maybe show you imperfections that aren't from your tool pathing. So you're going to have to spend a little bit of money to learn some of this. So figure out the best way to get some quality material at the cheapest rate. But you do want to make sure that they are surfaced and parallel and square. Otherwise, it's going to cause you some additional problems that you'll be fighting down the road. All right, we're at the computer and I'm going to jump into the Easel website so we can start walking through how to get this connected to your CNC machine. So you want to come to easel.com, and from here you can kind of just check out what they have to offer. They do have a free trial that you can check out. I believe it's about 30 days. And that will allow you to use all the full features of it. They do have a free version that will work for some things and some machines, but you may want to pay for the pro version to get all of the features out of it. That is starting at $16.63 a month. That's if you pay for a 3-year plan. Kind of goes up from there, but it is a nice way to kind of get started without fully committing to outright buying some of the other softwares that are out there. So once you are here, you want to get logged in with an account. So let's go through getting it hooked up to a machine. I'm going to have to jump into a new project first, or we'll jump into one of my existing ones. And the first thing we want to do is connect our machine. Now, it may pop up the first time and ask you to set up a machine. Otherwise, you can come up here to the machine toolbar, and we can go into Setup New Machine. And so you're going to want to first have your machine installed with the driver that came with it. Usually with a lot of these GRBL devices, that's a CH340 or 341 driver, similar with the diode lasers. and then you want to power on your machine and get it connected. So with that, we can go into start machine setup. And this is one of the great things about Easel is they have partnered with so many manufacturers to get their profiles set up in there. So you'll see a lot of familiar names here. And down here, we do have Sainsmart. And you will see in here, they have pretty much their entire lineup of CNC machines available that you can connect through this. So we are going to be using the Genmitsu 4040 Pro Max here. And so if we needed to set this up, we could go ahead and walk through these settings and hit next. It would try to connect, and it may have to push out a driver for the web browser to be able to connect with your machine. Go ahead and install that as well. And eventually you are going to have a machine set up in your software. Now, I already have that set up, and we can connect to it because as you see here, it's in my drop-down menu, the Genmitsu 4040 Pro Max. If you have trouble connecting it, sometimes you got to exit out of the walkthrough and then just come back in. You may see that it has appeared. From here, what we can do is dive into the actual setup of our materials. Over on the side here, we do have a number of tools that you can work with, from simple shapes, lines, drills. They have some advanced apps when you start getting into things like puzzles and maze generators, things like that, that can help you play around with different features. We are going to start out very basic, creating our own material or our own files from our own material. So the first thing we want to do is set up our material. I went ahead and grabbed a piece of 1/2-inch oak that we bought at the store. So we want to come up here to our material section over here. By default, it's jumping in at birch plywood, 12 by 8. Well, we need to make some changes to that. So we can click on the material type here, and we can scroll through some of their presets and find something as close to what we have. I'm going to go with hard maple for this one. It's going to be as close to oak as possible. Now we want to start entering in our dimensions. So the width of our item is 8 inches. The length is going to be 3.5. And our thickness again is 0.5. You may want to measure this exactly, especially if you're doing through cuts. On this one, it doesn't matter so much. We're not going to go that deep, and that'll be fine. The last thing here is we want to tell it where its XY0 is going to be. You can either have it be here in the front left corner, which is good for cut operations or square items. But if you're using kind of an oblong item or maybe a round item, you may want to switch this to center. And then when you set up your 0 point, you're going to want to reference the very center of your material as well. There are various reasons why you may or may not choose those. Generally, if you're engraving an item onto an existing object and you're not going to be cutting it out, that's a good time to use that center point so that you can actually identify where the center of your artwork is going to be on your material and zero off that. Otherwise, if you're using some square stock and be cutting out of referencing the corners and such, that's where we're going to want to go with the front left corner. So with that setup, that is great. Now we also want to look at our bit options. Now I did recommend earlier the SPI tools, and one of the reasons I recommend that is in here they do have some default bits, and I've added a few myself, but if you come up here to add a bit, you can start looking through some of their generic ones, but we can also come to add bits, and you see some of the popular tool makers over here, and SPI tool is one of them. So we could come in here and we could search for one of our bits. So such as the V-Groove 90-degree 1/4-inch shank bit, that is going to be right here. We've already added it, otherwise you could click add now. I had mentioned the Jenny bits from Cody and Cadence Manufacturing. They are actually under IDC Woodcraft because they do partner with them. So if you're using those, you can come here and you can grab those bit profiles as well. It's really great that they have these in here. It helps reduce some of the guesswork out of setting up your files. So once we have those added, we can then of course come down and select them. So we are going to be using the V bit. We are going to be using the SPI tool 90-degree bit that we added. So I'm going to click on that and then click out of the box, and you'll see that did change to a 90-degree V bit. Cut settings we'll worry about a little bit later once we get our artwork set up, but they do have automatic settings in here, and they do set up some defaults. Now I've adjusted mine already, but you'll probably come in here and find these at like 25 inches a minute and maybe 9 inches a minute plunge rate and in like a a 1/16 or less of a depth per pass. Though they're just setting up very conservatively so that if you are working on, you know, a much more light duty CNC machine, that you're not going to tear things apart. All right, so let's go ahead and we are going to make a simple nameplate. So we're going to come over here to the text tool on the right. We're going to click on that and we're going to select a font. Since we're using the V-bit, I do want to kind of show off the how it makes square kind of corners from this. So we're going to go with this Homestead font, and it has a nice square look to it. So I'm going to go ahead and roughly center that. I'm going to double click on here. We're going to delete where it says text, and we'll just put my name in there. And well, once again, I'm just going to visually center that. So as you see, as I'm doing this, it's adding a preview over on the right side here. So wherever I'm moving this on our predefined material, it is going to put that and give you kind of a visual reference of what's going to happen with the bit architecture as well as your drawing architecture over here. So this is actually looking pretty good. We do want this centered. We're not going to be cutting out the outside. We're just doing the name engrave here to kind of get our feet wet with running this CNC machine. But as you scroll in, you can kind of see the preview of what it's going to look at. As you look at the cut depth, I like to use the V-bits when they can actually go all the way down to a point, because if we go shallower than the depth of the bit, you see we start getting these flat areas. And if the shallower we go, we still have a nice defined point up here, but it leaves this flat area, and that does take a long time for that tiny V-bit to kind of carve out, and it's more likely you're going to get some lines in that. So I like to set this at the depth of where the end mill is going to do its best. So that should be at 1/4 inch. So we're going to just put in 0.25. And as you can see, we have nice sharp points here at the bottom. Everything's going to look good, and it will do a nice engrave. So this all will happen in one tool path with just one tool. Now is when we can look at our cut settings. As I mentioned, the default ones for this originally were much less. They were around 25 to 28 inches per minute. Plunge rate was really low. You can come over into the manual and adjust those settings. And so if you know that the CNC machine is more rigid, or if you've gotten some of the feeds and speeds from your bit manufacturer, you can start punching those in. We will have the opportunity to adjust the feed rate in the software as it's cutting the machine. So if we get that messed up, no big deal. We can speed it up a little or slow it down. So once we have all this set up, then we need to go attach the material to the workspace. And after we have that all in place, we can go ahead and hit carve. This is then going to walk us through double checking everything, which is really nice about this software. So we are going to start out by double checking, measuring the material. This is where having a caliper is very nice. Get a set of digital caliper, and that will give you a nice readout. Again, this is 1/2 inch material. I think technically it's going to be a little bit less than that, but we're only carving into 1/4 inch. Really doesn't matter on this one. So we're going to go ahead and confirm that. Now we do want to clamp down the material. All right, we're over at the machine, and here is my piece of oak. I am going to be putting this in here. I'm kind of finding a balance between these anchor points as to where I want to put it. So I might be able to get 2 side ones and then a couple of front and back as needed. We're going to be using the 3D printed clamps, and so I do need to make sure that these will fit and that I have the right length button head screw to go into our threaded inserts into our spoil board. Okay, that is going to grab. And now it's well in place, it's not moving around. So we know that our material is secure. Now we need to go ahead and add our bit. So here I'm using the end mill, the SPI tool. This is a 1/4 inch bit going into the 1/4 inch collet here. So we're going to slide this in. You want to be careful depending on the bits. Some of them will have a mark on here as kind of their minimum depth. These don't. We want to get it up in there so that that collet has a really good grasp on it, but you don't want it to bottom out into the router. So this one could bottom out if we took it in that deep. So I'm just going to pull that out just a little bit, and then just tighten that by hand a touch. And then we're going to use our wrenches. You got one that's going to hold the end in place, and we will snug that up like that. So the material's secure. We want to confirm our bit. We've got the nice 90-degree V-bit in there. Looks good. At this point, we want to adjust the machine to 0. And so with that, we can use our XY buttons to move it. You'll see the interval here. We can adjust this from inches to millimeters, however you feel most comfortable. But when you're just trying to dial it in close, you might want to jump that up to moving an inch at a time. And then when we hit the buttons, you will see that kind of move the machine a full inch. And then as we're getting closer, we can just kind of nudge it in a tenth at a time. We can go down to a hundredth and even down to a thousandth. Once you have that pointed on the corner of the material, then we want to adjust our Z. And again, we want to bring this down as close as we can. You're going to do that. And I like to use a piece of paper method when you don't have the probe. You can just kind of slowly inch that Z down, getting it just till it kind of grabs that paper. You don't want it pushing it into the material. You just want enough friction that it's a little bit tough to pull the paper, but it's not tearing it as it comes through. So you want to get that Z all the way down, just get that paper so you can just pull it out of there. And then we can go ahead and hit use new position, and that will set our 0 on those 3 axes. So now it says you're almost ready to cut. We can go ahead and we can raise the bit. That will bring it up. Our preset, this is about a 1/4 inch on this one. Then it wants you to make sure the spindle is on. We can hit spindles on, and then we go ahead and hit carve, and that will send the job off to the CNC machine, and it will start working through. So as the machine's running the job, you kind of want to pay attention to the sights and sounds. We're going to be listening for any bogging down of the spindle or the trim router. We're going to be listening for any like chatter or vibrations, and we're going to be looking for any burning happening on the edges of the cut. You also want to be looking to make sure that it's throwing chips and not sawdust. These are all signs of needing to maybe adjust our feed rate or the speed of the spindle. You see there, it's kind of coming up in the corners to a point, making those nice sharp corners. And here's an example of that, kind of doing the ramp in for the engrave. So as it's done, it'll go back to its home position, and we can then go ahead and turn off the spindle. So here is the completed V-carve. As you can see, with the oak, we're not getting a whole lot of extra fraying, maybe a little bit just down in there, but what we can do is grab a couple of wire brushes to help sand that out. Now, I did not have the dust collection going on because I wanted to help just see what was going on with the bit. And this is what you get. You get a lot of this little fine chips. And if you look at them, they're not so much dust, but they are kind of these fine little chip bits. You want to see more of that than just straight sawdust. If you're seeing sawdust, you're probably running too slow. You want to have a good chip clear out. You don't want dust. And so that's kind of what you're aiming for. But definitely look at some dust collection to help keep that off your work area and out of your lungs. But let's get this unbolted. All right, so this is looking pretty good. There are just a couple of spots, like I say, there's just down in here, there's a little bit of fuzziness. And so sometimes you can just blow that out. But if you are finding you have any frayed spots, get yourself a little brass brush and just kind of run that inside your V-grooves. That will help clean up just any remaining fuzzies that might be left in there. But if you have your speed settings right and your bit is clean and sharp, it should be giving you a nice edge, assuming your material isn't too porous and soft. That's why using harder material will actually give you some better successes right away. Another good tool is I have these little kind of just detail sanders. They have little Velcro strips on them, and this can also help just kind of get in there and clean things up, especially if you have any top surface fuzzies. But other than that, looks pretty good. Nice, easy way to add a simple name to an item. Now, of course, you could switch bits out and do a profile as well if you want, but wanted to keep this one fairly simple. All right, let's go ahead and set up our second project here. So we're going to go ahead and go to project and new. This will start the whole process again. This time I'm going to do like a soap dish. Here you see some examples of soap dishes. We could load them in, but we're going to go ahead and create our own. So we're going to need to start over with our material, and this time it's going to be very important that we get everything accurate. We are using some maple, so we're going to go ahead and jump back into the hard maple. Our width is 6 inches, our length is 3.75, and our thickness is 0.85 inches. So that will set up our block here. You can see over on this side, and now we want to go ahead and start designing our soap dish. So we're going to come up here to the shapes, and I'm going to grab a square. It's going to drop one in there. By default, it just comes an inch off of the lower left corner, and it's a 2 by 2 inch square. So we can start playing with these numbers. I obviously want to use more of this wood, but we want to leave enough room around the border. This is going to be the inside pocket that we're going to need an offset for our outside path. We also should go ahead and come over here to our bits, and we want to go ahead and add our second bit here. So that is going to be one of our speed tool bits, and that will be the spiral cutting bit. This is a 1/4 inch. I'm using an upcut bit because what came with the kit. A downcut bit would maybe work a little bit better, not to pull the fibers up on the edges, but we're going to go with that. So let's make sure we have that selected right here, and that will help make sure we get our settings correctly. So I want to make this a little bit wider, so let's go 5.25. And now we're going to adjust our position. Actually, no, I'm going to go 4.75 because this is the inside. And then let's adjust these to 0.75 and 0.75. Now, I'm thinking actually maybe 4.5. Now we're going to go ahead and add a radius to this. It will make the inside corners just a little bit less abrupt. On the inside, you're always going to have a rounded corner because the bit is round. We don't have square bits to cut square holes. And so I do want to come down here to our corner radius and go 0.25. Just rounds that out nicely. And that's going to be very helpful when we go to put our exterior path on as well. Now I am also going to adjust the depth here. We are going to take this down. It's about 0.85. I like to leave about 0.3 on all of them. So let's go with 0.45. It's actually about 0.4, but that'll be fine. This isn't too deep. We don't need it to cut too much out of there. Now what we want to do is right click on this, and we're going to create our offset. This is going to create our outside path. So 1/4 inch is just it always seems just a little too thin for me. So I'm going to bump this up to 0.3. We do want to go outwards on that. So I'm going to go ahead and hit apply. And now you see we've got an outside path, we've got an inside path, and our preview is starting to look like a dish. But we do need to adjust our cut on this one. We do need to go the full 0.85 deep. So we'll do that. And you'll notice it added in some tabs here. So if you were just holding the outside edges, once you cut that free, there would be nothing holding this. So our two options are to actually use double-sided tape to stick the whole thing down, or use tabs, use some clamps, or a mixture of both. I'm actually going to be using some double-sided tape on this one. So I'm going to go ahead and turn our tabs off. And then we will add some clamps to hold the outer pieces, and we will have the tray working on the double-sided tape to hold it in place as well. All right, we've got our piece of hard maple here, and I am going to get that affixed down here. Now I want to try to have clamps on the side as well as using some of the hold down tape. So I got to make sure that these will work on here. And I think they will. I'm just going to need to swap out for some longer screws. So it's good to have a kit of variety of screws. I've got some longer ones that will give us some reach there. And I'm going to go ahead and put this down here with some tape. So I want to make sure that that is fairly clean. We're using some of this light duty indoor carpet tape. And so that's the side we want it on. Should have used a longer pair of scissors. There we go. Now the bit is going to go around the outsides, and it could hit the outer edges. So I just have to decide here if I want to put them on the side or on the edges. Because I could do that, or I can do the sides. I think I am going to do actually the front and back, since we have some tape holding these down. I didn't quite get it all the way to the edge, but I could go the full width of it, but experience shows me that might make it a little tricky to pull back up. So once again, I'm using my grid lines, get this fairly square, and we'll push that into place. Now at times that's been enough, but never hurts to go a little bit extra. So that's all nice and firm. These should be well out of the path. They're gonna probably come close, but no big deal. 3D printed, I can easily make a new set. Now we need to swap the bit. And if you're using one of these ER11 collets, they're kind of like a double locking nut. So when you go to loosen them up, you will pop them loose once, but then they will grab again. See, I can't pull that out yet until I loosen it up a second time. Just try to make sure that doesn't drop out on you. We'll go ahead and put this back into its case, and we'll swap out for our 1/4 inch end mill. You want to be careful. Some of these can be fairly sharp. Again, we're wanting to get that seated properly. You don't want to go into the cutting flutes, but you want it up far enough that it's going to capture it fully. And then we want to make sure it's snug down, because there's nothing worse than a end mill that comes loose during your project. Generally ruins the project and can be dangerous. All right, now we are going to go ahead and move this back to the corner, get it squared up. We'll do all that through the software. Again, we're going to double check the measurements. That's where having a good caliper is helpful. We want to make sure it is clamped down. We went ahead and added the double-sided tape and the clamps to it, material secure, confirming we're using the 1/4 inch upcut bit. And now we want to adjust, bringing that bit over into the corner. With using a larger bit, sometimes you have to eyeball the center, and since we're just cutting out a material, this is working okay. So once you have that set, we can go ahead and hit use new position. Then again, raise the bit, turn the spindle on, and hit carve. So as it first ramps in, we want to pay close attention, make sure that it's not chattering too much. It is cutting on both sides of the bit, so it's a little awkward on that very first cut, but as it continues the pocket, it should clean up. Just wanting to make sure that we're not getting a rough cut anywhere. The other thing you're going to want to watch is as it gets deeper into the pockets and it's cleaning out that edge, that is leaving a nice clean edge. They're not getting real witness lines there. That can be an issue with tramming. We're going to start the outside cut here. Once again, that can be a little aggressive, so you just want to make sure that your speeds aren't too much. And that upcut bit is helping to pull those chips out of this channel. If you had a down cut, it could be packing them in, but everything went smoothly. It's going to go back to home and we'll turn the spindle off. All right, that job is complete. And once again, this is why you really need dust collection. It does fling a lot of chips around. It is good that we're seeing these small chips and not dust. It means our settings were not moving too slow, and we weren't having the router go too slow of a speed either. But as you can see, this is why you want it. You don't want to get a lot of that dust on those ball screws and those rails. So future jobs, I'm definitely going to be running the dust collection, but wanted to kind of show and watch the bit working and see how these worked. And we'll get this cleaned up and take a look at the tray. ShopVac's going to make quick work of this, and some compressed air will clean off those ball screws. So there you have it. We did a quick name engraving using a V-bit on this little piece of oak. Came out pretty well. And this kind of catch-all soap tray, little coin dish or whatever, using some pretty simple bits, using just the benchtop 4040 Pro Max from Sainsmart Genmitsu. So hopefully the primer with Easel showed you kind of how to get this set up and connected, and how to set up a couple sample jobs just to kind of get your feet wet, get started working with your CNC router. So if you have additional questions or projects you'd like to learn on this, whether it's on this smaller CNC or one of our others and using Easel, let me know. Always like to make content that helps you guys out, and hopefully it will spark someone else's imagination as well. If you are interested in the CNC router or any of the bits, any of the materials that I used, I will have links down below to as much of that as I can. Some of them will be affiliate links, and by using them, I do get a small kickback at no extra cost to you. It's a great way to help support me. So I thank you for watching. Hit that like button on the way out. If you're new here, consider subscribing. Throw a comment down below. All that goes through to help the YouTube algorithms, help other people find my channel as well. So thanks for watching. I hope you enjoyed it. Most importantly, I hope you get into your workshop and make something too. We'll catch you next time.